Hey everybody, this is Larry. This is me going over Q4 of the recent by the Leetcode weekly contest, minimum operations to make a subsequence. So this one, I think there are a couple of ways to think about it. I think there are two main solutions that I've seen and variations within those two things. So I'm going to go over it at a high level really quickly. If you have trouble with it, I'm going to give you keywords to kind of other prompts to work on, so that if you do have trouble with it, then then those are just things that you can do, so that if you have trouble with it, you can work on those prompts, and then you could come back to it, and it will make a lot more sense. So the first thing to notice is that n is very big, right? So maybe the naive dynamic programming solution is going to be n squared, the longest common subsequence. The key thing to note is that target it contains no duplicate, and that is the key of figuring out how to solve this problem for a lot of people. And there are two ways to do it. I'm going to go over the way that I didn't do it first, which is transforming this problem into an LIS problem. And LIS is longest increasing subsequence. It's an n log n solution that's a little bit tricky to understand for beginners. So if you're having trouble with that, definitely work on other longest increasing subsequence problem. But the idea is that, okay, so let's say you have this input, or maybe even this input. Let's say you have these two inputs. The idea is that just changing. Okay, here we map this to 0, 1, 2, 3, 4, 5, 5, and here we change all the numbers to basically what we map them to, or not if they're not existent, right? So this would be 1. This would be 1. 7 would be, say, -1. 6 would be 0. 2 would be 5. 3 will be 4, 8 will be 2, 6 will be 0 again, and 1 will be 3, right? So then given that, it becomes a longest increasing subsequence problem on this array, and the number of numbers that you have to insert is just the longest increasing subsequence, or n minus the number of longest increase, the answer of the longest increasing subsequence. Because basically what you're saying is that from this array, make this bigger, from the target array, we want to go from left to right, and we're going to skip some numbers. So essentially we want the longer, and because they're unique, these numbers is not going to, because they're unique, all these numbers are going to be unique with respect to what it's mapping to, and because of that, longest increasing subsequence will mean that 5 just means the fifth element, right? And then you're trying to go from 0 to 5 using as many elements as possible, which is why the longest increasing subsequence solution works. Again, I'm not going to go into detail for this problem. I think this is quote unquote straightforward once you make that connection, and with the prerequisite that you understand longest increasing subsequence. So definitely train on that. The way that I did it is actually using binary index tree, and there's the same thing, except for you can also use what's called a segment tree, which is probably the better answer, to be honest, because I think this is a more natural segment tree solution. But I don't have a segment tree ready. I don't have binary index tree ready either, so I had to do it manually. So I find binary index tree easier to write, but I also just have to learn segment tree. So that's just me. But in terms of interface, you can do them interchangeably. So for this problem, what I did is, okay, again, I have this thing here to map this to the lookup table, and then from that, it becomes a dynamic program problem of, okay, let's say this is 4, right? 4, the max number 4 is that basically we want the smallest number that, we want the largest number in the same idea, except for now we want longest common subsequence. And the longest common subsequence, in a way, the way that we're doing it, takes advantage of the fact that there are no duplicates by saying, okay, so we start with 4. 4 is going to be the first element, so let's just say this is 1 because now we have one element that's common. 7 doesn't do anything. Say 6, 6 also 0, so we have one element that's common. 2, what does 2 mean, right? So 2, we see that the lookup is 5. That means that we want the smallest value of things that appear from here, right? And actually, let's remap this. So 4, we want to say that the shortest, let's see, the max number of elements that that includes 4 or 6 in the prefix is 1, and 6. This is also 1, right? And then 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, right? And then 2. The idea is that, okay, 2, we look at 5. We want the max of these numbers because the max is equal to, given the prefix, the number of characters that we matched in a maximal way, right? And here the answer is 1. So then here, matching the 2 will give us a 2 answer, meaning that the longest common subsequence has a length of 2. And then 3, in a similar way, we go, okay, what is the longest common subsequence of all the numbers to the left of this, which is still, 1. So then now the longest subsequence that ends at 3 will be 2. 8, same thing. So then this is 2. 6 again. Well, this is still 1. This is so 1. Well, now to the left of this, there's this. Wait, did I get this right? Yeah. 1 to the left of this is 2. So that means that now adding 1 to and 8, for example, because what 8 represents is that there's a sequence that ends at 8 that has 2 common characters, right? And if you add, oops, how did that happen? If you add 1 to any of these previous sequence, then you're able to get that number as well. So basically, that is the longest common sequence solution that I got. And once you get the longest common sequence, and you get the max of all these numbers, then the answer is just n minus the longest common, because then you have to insert the numbers that are not in it. And that's basically what I did. And you can, going back to what we said, all we keeps on doing is querying the prefix for the min, right? So here, for example, when we saw the 2, we queried the prefix for all these numbers and getting the min. If you do this in a naive way, then it's going to be n squared, because it can be like 0, 1, 2, 3, 4, 5, 6, and you look at every number every time, it's going to be n squared. But if you have a data structure like a segment tree or binary index tree, then you're able to get that prefix in log n time, and that's pretty much it. And that's what I did. I have a binary index tree, as I said. I do this thing where when I set it, I go up the tree and I set the max. And again, when I get it, I go down the tree and I set the max. I set up the lookup table as we said to get the prefix, to kind of get how many elements are smaller than that. And we only use this and we can ignore elements that are not in the original or not in the target array. So we basically just did what we said here. This should be straightforward. It took me a long time for this because I kind of mixed up the signs. I did the minimum during the contest because I was thinking, okay, but then I was optimizing a harder function that wasn't true. But now, this is good. Yeah, so the complexity of this, for each element, we have a lookup table, and then we also have a segment tree. But for each element, we do 2 queries, which takes log n of time, log n times each. So this is going to be n log n. And in terms of space, of course, it's going to be linear space because of the lookup table and the segment tree. Yeah, that's all I have for this problem. I took a long time during the contest because I was just stuck on Q3. But otherwise, I actually thought this was pretty straightforward. And actually, I like this problem a lot. I wish I did Q3 in a quicker way so that I could focus on this, and I think I would have gotten it quicker. But yeah, let me know what you think. And you could watch me solve it live next. I don't think I'm going to solve this, but okay. Yeah, like, well, 15 pros out. This was, I don't know that this is so much better, but okay. Um, subsequence of OA. Usually this is just DP, but obviously this is some greedy thing now. Let's see. Might still be DP actually, but just in a more subtle way. I really wish I got the first two without the two wrong answer submissions. So I think that may be good enough for a high score, but I'm going to drop quite a bit unless I get one somehow. So this is unique. That is the thing. This is two. What does that mean? prefix is such that min. This is like a segment tree thing too. No, it's definitely a segment tree. I don't think you could do a like I'm trying to think whether I can use. Is it segment tree? It's min such that. Yeah. Okay. If only I have this pre-written. Maybe I should pre-write it next time. I don't know if I need that. Actually, I don't think I need this. So used to writing I don't know why I changed it for this problem. This is wrong. It's kind of what I want, but not really. Should be that plus the index. I mean, it's kind of right, but not really. So I want that delta, so this should be is the difference in index and the prefix. So it's the min of all those. Wow, I mean, maybe I just don't know this one. Wow, a lot of people got this one though, so it is going to be a sad day for Larry. the min here is I optimize too much. So what I want is something like y in and like something like that. Something like that actually. Yeah. But I'm trying to reduce this function. I just don't have the energy today. Maybe I should have set out not grinding, right? This is the function, but it's gonna be n square obviously, so how do I optimize this TP? I thought that I could do something like this, but I was wrong. Because you don't, the reason why this is wrong is because you don't add a constant for all the numbers. And I don't know how to optimize this. And this one I just have legitimate have off by one issue. I mean I have this recurrence for dynamic programming. That's already a little bit better than the naive, but I think I'm doing the wrong thing. So I could do the inverse of this, probably. So then we just take the max. Oh my, come on. How do I have the same typo twice? Okay. Just something like this. Well, it's close. Huh, so I was really close, but I think I forgot to think about the inverse. Hey everybody, yeah, Happy New Year. Thanks for watching. Let me know what you think about this poem. I had a rough contest, but sometimes it happens. So, don't feel so bad if it happens to you either. But for me, need to be more consistent. Let me know what you think about this poem and whatever. I will see you later. Bye-bye.